engineered to strike the perfect balance between size and power. This is Pivot. The outer shell is made from durable and lightweight carbon fiber mounted on a precision-cut aluminum frame, making it a tough and reliable vehicle for any mission. Hardware and software have been precisely optimized to increase performance, portability, and efficiency. The immersive Full HD camera gives you 220 degrees range of motion, so you can see clearly what's above and below you to make missions fast and efficient. 97 degrees of tool articulation make imaging systems like sonar and tools like our grabber arm convenient and stable for any pilot. Weighing in at just 37 pounds, portability meets unmatched power for the ultimate submersible ROV. Our bridge technology enhances your for an improved viewing, operating, and data recording experience. Pivot is nimble. The 6-thruster configuration lets you maneuver laterally, pivot effortlessly, and withstand strong currents, making jobs like hull or net inspections simpler than ever. Deep Trekker's latest sensor integrations and software advances allow for semi-autonomous navigation through Pivot's unique, scalable design. This is a brand new, world-class ROV. This is Pivot.
Good morning, everyone. My name's Alexander Gold. I'm the technical trainer here at Deep Trekker. I pilot these ROVs on a daily basis. I just want to welcome you to our live launch of our brand new ROV. This is the Pivot. So I'm not going to get into any details right now. I'm going to pass you off to our president, Sam McDonald, and one of the founders of the company, and also our head of sales, Cody Warner. They're going to give you a little bit of an overview. Right now, they're in San Diego at a conference down there promoting our new robot. So it's very exciting. We're back to traveling, going around the world. I'm going to leave it there and you'll come back to chat with me a little bit later in a Q&A session. So let's pass you on to Sam and Cody.
Thanks, Alexander. We are so excited about this new product launch. I'm Sam McDonald. I'm the president of Deep Trekker, and I'm here with Cody Warner, who's the sales manager on our team as well. And we're coming to you live from the Maritime Museum in San Diego. You know, this represents the 9th product launch that we've done at Deep Trekker, the 9th robot in 10 years, which is phenomenal. But I have never been so excited about a new ROV as I am about the Pivot. Now, the Pivot is the perfect balance in our lineup of remotely operated vehicles between the portability and the ruggedness of the DTG3 and the sophistication of the Revolution. The Pivot is coming right in the middle. It offers you that portability. It's got the same thruster configuration as the Revolution, so you have that stability in high current. You've got the vertical thrusters for powerful movement through the water column, all in this fantastic compact package that could be handled by one person. It's also really rugged, and Cody's going to tell you about some of the features that we have on the Pivot.
Yeah, for sure. There's a lot of great different features that make it special, but the first thing you notice when you pick it up is that it's just really well built. It's very tough. The underwater world is not a forgiving environment, so you want to make sure that he's really, really tough. Some of the things that make it so durable, you've got a nice carbon fiber shell. All the components on here are either stainless steel or aluminum. We've got our rotating camera head that has heat-treated steel alloy gears. We've got our magnetically coupled thrusters. This is what really sets all of our systems apart because it means that it's a really low maintenance system. They're really long lasting, durable, meant for the harsh environments. We also have our handheld controller that runs the whole system, the whole family of systems here. But what makes this controller so special is that it's also built tough. We've got our Hall effect sensor joysticks that make sure there's no water ingress through it all. We've got a completely splash-proof system, nice big screen, and all the video outputs on there in case you wanted to output and live stream your inspection reports as you're going.
People really love the controller across all of our systems. And of course, we're going to bring that with the pivot as well. And the reason that the controller itself is so popular is because it really adds to that portability factor of all of our systems. And the pivot, like the Revolution and the DTG3, is battery powered. So you don't have to worry about bringing a generator. You don't have to worry about having mains power on it. We do have swappable batteries on the pivot. So we bring 2 sets with you at any time. You can keep those charged up and swap them out as you need to. We are also coming out with a direct power model of the pivot as well. So you can have the best of both worlds. Simply slip out the batteries, put in the direct power module, and you can have that all day long running of the ROV if you need to as well. And like Cody said, you know, this is really being able to withstand what's in the water. I don't know what type of pilot you are, but I can tell you that I'm running into things on the regular down there. So we made sure that we have all of the capabilities that are in all of our products for that ruggedness in there. But I can pick it up. So coming in at around 35 pounds, this is something that I can handle straight out of the box. The setup is really, 30 seconds to a couple of minutes maximum. You're in the water, you've got eyes on your issues, you've got eyes on your infrastructure, you've got, eyes on your shipwrecks if you're lucky enough to be doing that as well. Really, really quickly and really, easily as well. But that doesn't mean that we can't have sophistication as well. So on the pivot, we can have advanced positioning systems like USBL. We've got a DBL installed. We do the sensor fusion for positioning of the IMUs and the DBL and the USBL, and we can translate that into maps so you know where you are at all times and also know where you've gone. We do offer a variety of different sonar options on the pivot as well, just like the Revolution and the G3, so that you can find things from far away or really get a high quality image of a close-up. So looking for things like cracks in walls. So we offer a variety of different options there. NDT tools, non-destructive testing tools. We can put Cygnus thickness gauge on this. You can use this to check the thickness of a hull, looking for corrosion. And one of the cool things about this is the way that we integrate the tools. Cody, can you talk a little bit about the why we called it the pivot?
Yeah, it's one of my favorite features of the system is this tool platform here will actually rotate. So we'll show you a little bit of a rotation here. It can actually rotate 97 degrees. So what that allows you to do is put various sensors or tools on that platform, and now you've got a really flexible way to be able to maneuver them around. And because the camera is separate from that tilting platform, you can get whatever kind of look that you want to get, so that you can make sure that you're looking right at your tools as you're operating, or if you want to be looking straight at the target while you're operating your sonar, you have all that flexibility. But the nice thing about being able to rotate something like a sonar is that, let's say you're doing a search and recovery mission. You want to be able to have the optimal angle depending on the depth that you're able to hold. You want to be able to make sure that you're getting that nice clean image, and sometimes that means adjusting the angle of the sonar. Being able to adjust the angle of the sonar without having to actually move the vehicle itself gives you a lot more flexibility while you're moving. You can also use it for surveys, hull surveys. You can have the sonar be facing upward on an upward trajectory and be able to get a nice image of the hull. If you're looking for tick boxes, if you're looking for major defects through murky water, the sonar is really helpful for that. When you're using the grabber, you sometimes can't pick something up if you've got it held on a horizontal angle. You want to be able to adjust what angle am I facing so that I can get a good grab on an object. Oftentimes you're going to be on a 45 or on a 90 to pick something up. So the tilting platform lets you do that. But then there's also a variety of other tools that you can put on it. So if you wanted to put on a multi-parameter sonde, or if you wanted to put on a CP probe, all of those things, there's lots of ports that you can plug into, and there's a lot of different ways that you can mount the different systems. We've got that tilting platform, but we also have the side skid here, which allows you to have even more flexibility with what you want to do with the tools.
I'm always surprised by what our customers are going to do with the ROVs next and what we've integrated for our customers over the years. And we've been able to do that because we have our powerful bridge platform. And that's I call that the brain and the spinal cord of the system, but it really is allowing customers to take really complicated missions and make them simple. So put your positioning systems on there. We've got them integrated. Put your sonar, shows up right on the same screen of our handheld controller. Add the NDT, add the environmental tools. We can do it all. We have the ports to do it, and we have the team to integrate it. And the team is one of the most important things at Deep Trekker, when we set out to make the company, we wanted Deep Trekker to be a company that we would buy from. We know that things happen. The underwater world is indeed harsh. And occasionally, you're going to need some support with your ROV. And we have the best, absolutely the best support team in the entire ROV industry, and really across all industries out there. We've got a great team of technicians that are always at the ready. If you want to talk to the engineers, we have them available as well. We really want every single member of the Deep Trekker customer family to be 100% satisfied, and that is really important to us. And of course, that comes with the pivot as well. We have a variety of different warranty options to make sure that you're up and running all the time. We know that the work that our customers do is mission critical. We know that our systems are used in really important missions, finding evidence, finding lost souls, involved in the energy industry, making sure that the lights and power are staying on, involved in water systems, making sure that there's clean water, drinking water, and sewage systems are up and running. And this is really important to us, and it's important to you as well. And we want to make sure that our customers have the highest amount of support so that they can do the work that they do best. And that is what makes the Deep Trekker different. And being a part of the Deep Trekker family is different as well. So this is the third in our lineup. So we have 3 official remotely operated vehicles, reminding you we have the DTG3 in the small size. That's your quick out of the box, ready to go. We've got the powerful Revolution with its stability in the water and ability to take on those deeper missions. And now right in the middle, we've got the Pivot. We're excited about it. Of course, we're pretty happy to be using it ourselves, but we're not the only ones. So I want to give you the chance to hear it from one of our first trial users of the Pivot. So Blake Spittle from Complete Waters had the chance to take this out into the water and give us some early feedback. And here's what Blake had to say.
I was hoping to confirm its maneuverability and its stability in the water. It's great, it fits right in that box. It's quite a light machine, nice. After having the G3, I've got 2 G3 units, and they're fantastic units for what I do. In natural water situations, I'd be looking for a little bit more stability in high flow waters. And more smoother video for the clients in civil infrastructure inspections, or those submerged infrastructure inspections. So day to day is mostly submerged infrastructure inspections. That's typically a day. We do have a run of aquatic habitat surveys. It's a nice simple setup. So I think the features of the Pivot, it will be a huge benefit to our underwater imaging services. Yeah, it's so simple. That took probably under a minute, to be honest, to be fully set up and ready. So that's really nice.
Cool. So left joystick is going to be just like the G3 is your normal motion. So forward, back, yaw left, yaw right. Yep. Your right joystick is now, instead of pitching, is now going to go up and down. So this is going to sort of follow what you already think about the G3, which is why it's the sort of base is set this way. So if you push forward, normally that would be pitching forward on the G3. It's just going to go straight down. Okay. If you push side to side, it's now going to move laterally. Right. Okay. And the best part about that is when you get up to an object, if you apply a little bit of yaw at the same time as some lateral motion in the opposite direction. So if I move to the left and I turn to the right, I'm now orbiting around. Remember, your speed gain affects all motion, forward, back, left, right, as well as up and down. And then your lateral motion is basically the same. It's quite zippy.
Really nice. It's a really nice clear picture. Really smooth. It's got a great smooth motion to it. Holds its depth really well. I like how it's such a portable machine. You can launch it, just one person, but yet in the water it feels so solid, which is really neat. We're trying to create a service using the right tools to create a small footprint on site for clients, so we can keep those costs down. We can keep health and safety concerns down, but we believe that if you use the right technology in the most efficient way, then you can have a really efficient workflow on site. So a lot of the work that we do is just one person turning up to do the ROV work. There's no large technical teams, there's no large, huge technical supporting equipment. It's just the right skilled personnel with the right tools, and yet we can generate the same results as the larger technical companies. So really nice, yeah. Really nice lateral movement. And the fact that you can change the speed gain of it is a really nice feature. Yeah, I do a lot of civil infrastructure inspections and tank inspections, and having that lateral movement for an inspection is really key, because it's giving you a nice smooth video. The depth holding's excellent. So in terms of inspections, looking at submerged infrastructure, that's a really, really nice feature. And the fact that you can slow it right down, speed it up, will be hugely beneficial to civil infrastructure inspections. And giving you a nice smooth video as well, which is key, because the client is looking for smooth imagery, not so worried about how you get it done. You've just got to get it done. So having a tool that's this smooth is going to be critical. And how it holds itself too is so smooth, and it's gonna result for me in less video editing too for the client, right? So less time behind the computer editing video and photo. At the end of it, your video straight from the ROV is so seamless, which is also a huge benefit. Yeah, so a lot of clients, like they're not so worried about the tool that you use or how you do it. They're worried about the end product that they're receiving in their hands and how you go about that. If you can create the most efficient workflow as possible by using the right tools, then it's far more efficient for you after the fact. You get back in the office, you only got so much video to edit, or you've got no video to edit because the video straight from the ROV is such quality. Right.
But we actually have an auto white balance function, or you can go in and manually adjust the white balance.
Oh wow,
so
okay.
That's an improvement.
That's pretty cool.
Yeah, it's coming in the...
That's really nice features, because all the water that you go into is all different, right? So being able to change those parameters is a nice feature.
Yeah.
Yes, the sonar feature on the pivot is definitely beneficial in Ontario waters that I work in. It's not something that I've used to date on my G3s, but I could definitely see its benefits for sure. A lot of waters around Ontario are more turbid waters, so I think it would have a lot of benefits, yeah. So that depth holding feature and holding its altitude off the bottom is so smooth. It's really nice. I also do a lot of aquatic habitat surveys, recording, videoing fish habitats. So being able to have your station depth holding and running straight lines is key for that kind of work. So it's such a solid machine, it's probably not going to get thrown around as much as other ROVs. It's going to hold its position well. So completely different to the G3. I'm so used to the G3 and the unique pitching of the G3, which is also very, very useful in certain scenarios. We do a lot of water tanks that are very tight access. So the G3 is very beneficial in those circumstances. But I think for our larger waters where we've got a lot of current and rougher waters, I think something that's as stable as the pivot is going to be really beneficial. And yet it's still very portable. It's still basically a one-man show. So yeah, the more I play with it, the more I'm falling in love with it. Very impressive. It's I just love that it's still a one-man, in my mind. It's one-man portable. It's easy to launch. It's so solid in the water. It's got great movements. It feels really nice on the controls. I think as an inspection and survey tool for ROV services here in Ontario that I operate, I think this tool is a great way forward. Really excited. I was hoping to confirm.
Hey everybody, it's Alexander here again. So I hope you've enjoyed what you've seen so far. Blake is an excellent customer and a really interesting guy. He's quite knowledgeable. So that should give you a good idea of what it's like to actually take the unit out, put it in the water, drive it around, see what it looks like. And his reflections were quite positive, which we were very pleased about. So now I think it's time for us to go to our question and answer session. I've got a few people helping me here watching the YouTube chat. So if you have any burning questions, type them in the chat and we'll have some of our Deep Trekker staff read those questions out to me. I briefly looked just before we cut to me for the first couple questions. The first question I saw is there a net repair tool, a way to weave nets back together in salmon farming? So short answer is sort of. We have a really cool tool. It's a temporary fix called the net repair tool, and it should work with a pivot. I've seen it set up with the Revolution and the G3. Essentially, all it is something that connects to the grabber arm and can sort of open and close. And what we have is a piece of netting with hooks on the end and two large springs. So if you drive the ROV up to the net and then basically close your grabber, those hooks will squish together. The grabber and sort of the little attachment bracket will pull away, and then those springs are going to pull your little net patch over top. I have seen from another company a setup where they had some kind of system that actually wove a cable back and forth. We've been looking at that, and I know our engineers are looking into designing a version for ourselves. So there's a ton of stuff in the process of being built. So that's a design that we were very excited about. Right now, it's the net patch kit, and you can see some videos of the Deep Trekker net patch kit if you search for it on YouTube. JC, you got another question for me? So the unit is set up with 4 vectored thrusters. You can basically think of this as a little Revolution. We actually took some of the same hardware. So these are the same powerful thrusters of its larger brother, the Revolution. We just did a few things to try and make it a little physically lighter. Like the propellers are now actually a polymer rather than metal. So we're just shaving off grams here and there so that it makes a more transportable tool. So they're quite powerful. Their thrust power is scaled down a little bit from the Revolution because obviously it's a smaller unit. The batteries are a little smaller. We don't want to run out of power, but we're able to move quite quickly. So we've got a max speed of approximately 2.5 knots forward. I'm not entirely sure off the top of my head what the sideways speed is. I would imagine maybe half of that. So if you're sitting in current, I would say 1 to 1.5 knots maximum horizontally. And we do have, like Sam and Cody touched on, we do have these different navigational tools, including our Doppler velocity log sensor, which is something that connects to the bottom. It uses sonar facing down towards the bottom of the seafloor, and it can feel and sense its horizontal motion, calculate velocity, and then automatically fire up the thrusters to counteract that horizontal velocity. So I would say up to 1, maybe 1.5 knots horizontally, you'll be able to just automatically hold itself in place. Now, if you're dealing with something that's much higher current, there's a lot of solutions in place. The first one, just like some of you may have experienced with the DTG3, is basically pointing the ROV into the current. And so I'm doing my inspection or my mission going up and down with the current. The other things that we start to see when we're looking at current issues with ROVs is the tether getting pulled along. So the more tether you have out, the more drag there is. And if you're operating at 200 to 300 meters, like this guy can go down 300 meters, that's a lot of tether, and that's a lot of drag. So there's something that I've learned in my time as a technical trainer from more experienced ROV pilots, and there's something called a clump weight. So what you can do is actually attach a large weight to the tether, 5 or 10 meters from the back of the ROV. And so the tether is going to hang straight down from your boat, and it's going to be held taut in place, not really swinging too much in the current. And then I only have that 5 or 10 meters loose, which is going to be adding drag. So that's a really nice way to counteract current. This also works in rivers. We've seen some search and rescue teams do this when they're looking for drowning victims or doing evidence recovery. They'll use clump weights to try and keep the ROV at least relatively in position, and they can move side to side within the heavy flow. Okay, so the power requirements for direct power, essentially you should not need to do anything different with your pivot. You're going to basically swap out the batteries the way you would normally swap between the two sets of batteries that come standard. And instead of putting back in the battery, you're going to put in a special tube that's connected to a thicker tether. Now, the direct power systems that we have, I believe, are currently 9 millimeters in diameter. So it's a much thicker tether than what we're accustomed to. You know, the battery power is what gives you the sort of light flexibility of this tiny tether. So you're going to end up with more weight and more drag, and obviously less tether on the reel. I understood, and I could be wrong here, I understood that a standard direct power kit comes with, I think, 100 meters of tether. But again, you know what, that's a question where we'll have to follow back up with Sam and Cody with the MSRP list. So you're going to be able to go as long as your tether is. It's just a matter of how much tether can you fit on a reel and how much tether are you willing to set up. In theory, in terms of communication protocol, with the essentially the Ethernet connection we run, we can fit up to 800 meters, or we can run our connection up to 800 meters. But I think 800 meters of powered tether would be incredibly cumbersome and would take like a giant case with a giant reel. So I don't think we've set anything up that's quite that large. Our standards now, I think, are 100, 150 meters with the current protocol. And then again, this is always an evolving technology. We've got a rapidly growing team of engineers right now. I believe we've got 22 engineers and lots more coming. So we're going to see stuff like this improve and change for the better at a pace you've never seen before. Depth is 300 meters for this guy. Oh, tether, yeah. So I always describe it as Batman's Ethernet cable. So essentially, we've got two twisted copper pairs on the inside. The tether is designed by our engineers in-house, and we've got a custom manufacturer build it for us. They ship it to us by the giant reel, and then we cut it down into smaller portions and wrap it onto the tether reel. So the tether reels are basically built in-house, but the tether's manufactured elsewhere. So on our custom design, we have the equivalent of what would be like an Ethernet cable, but the copper wires are actually thicker, and that allows us to have a better quality or higher bandwidth over a longer distance. And it also helps to make sure that if you do have chronic abuse of the tether with a lot of stretching, if that copper does get stretched out a little bit, you're still going to have pretty significant bandwidth. So we've got our two twisted pairs, they're insulated, and we've got some reinforcement strands wrapped around them. And then all of that is bundled together. And then there's a woven sheath, picture like the outside of a rope, of reinforcement strands. And the reason I call it Batman's Ethernet cable is because those woven strands are a form of molecule that's very similar to Kevlar. Kevlar is a branded product, so it's not actually Kevlar. It's like one atom different, but it's got exactly the same properties. So you've got this super strong sheath of almost Kevlar fibers, and then you've got a yellow rubber jacket over top. And then you'll notice in some parts, so the bottom 5 meters, just going to yank a little tether from over here, the bottom 5 meters of the tether, and also all the connections that are on the top side, so between the controller and the tether reel also have this nylon sheath over top. So the nylon sheath is not adding any real tensile strength, but it is preventing abrasions. And over the 10 years that we've been producing ROVs, we've noticed that when you have tether issues, it's usually from deployment and retrieval, and it's that last bit of tether that's getting caught on stuff while you're pulling the ROV out of the water. So this is going to help prevent any sort of cuts and abrasions getting into the rubber. We can also, and have for some clients, sort of custom built this so that nylon covers the entire tether reel. So if you're in really harsh conditions with lots of sharp metal objects, that might be important, but obviously it's going to add a lot of weight and make the tether a little bit more cumbersome. So
okay, so let's go.
Great question. So the sonar, oh, I forgot to turn this unit on. So the sonar on the pivot is basically sitting, JC, could I grab you for a second? I'll just, oh, could I just get you to point the camera closer to the pivot shelf here? So the sonar is mounted on this horizontal shelf here. So we're basically able to get 97 degrees of rotation. So this is a little bit less than what we're accustomed to with the Revolution, but it's a much more stable, smooth platform than what we'll see on the DTG3. The unit's just booting up, but essentially this shelf is able to rotate from about 7 degrees above the horizon to fully 90 degrees straight down. And because your sonar has a spread, obviously it depends whether you're high or low frequency mode, but in low frequency mode, when you've got that 20-degree spread, that means that my sonar is going at least 17 degrees above the horizon. So if you're close to the surface, within 3 or so meters of the surface, at least in my experience so far, I'm actually able to get a sonar scan of things that are above me, which I think is really important for navigation, especially in harbors and marinas where the seafloor kind of all looks ubiquitous, but above me there's a very clear pattern of infrastructure that helps me navigate. Why are the lights outside? Okay, so the pivot right now has 2 sets of lights. So I've got primary lights that are connected to the main camera here. So you can see the main camera in the center, and I've got 2 sets of lights here. So these are inside, I guess you could say they're inside the robot. I mean, the whole thing about deep tracker robots is that they're modular. Even this unit, although it looks like it's sort of one solid box, I mean, it is quite solid, but each component is sort of its own thing connected with a tether. So the grabber arm is held in place by a few screws and then a tether that comes into the main body. Each thruster is held in place by, I think, 4 little hex screws and then as a tether. The same thing with the batteries, you pop them in and out. If I wanted to replace the cylinder here, I would just unscrew it, and then everything is sort of just bolted onto the frame with a tether connection. So the lights on the outside are going to be the same even as the camera head. What's interesting, we've actually got some cool improvements coming on these lights already. We've got a really neat design in mind where we're going to have a cylindrical sort of piece of metal here, so it's solid. And rather than just having a single LED panel, we're going to have a set of 3 LEDs. So you'll have a really nice widespread. It's going to be much brighter, and it'll also be manipulatable. So if I know I'm doing a hull inspection, I might point my lights, or at least some of my lights, up, or I could have one set of lights pointed up while the other set of lights pointed down. I don't know if I really answered the question of why they're on the outside. I guess the other thing that I would add to that, generally speaking, when we're thinking about underwater photography, we want to get our lights as far away from the camera as possible. Now, obviously, we're trying to do a small, compact ROV, so there's only so far away from the camera that I can place those lights. But if I can get my lights, half a meter to either side of my camera, picture like a professional underwater videographer rig, you're going to have your lights pointing out here, and those lights are going to shine out in cones. And my goal is to set those lights up so those cones intersect at the point where the object is that I'm photographing or videoing. And that way I'm not getting any bounce back from the particles directly in front of me. I'm just seeing very clearly that object. The thing is with this ROV, I want to be able to see stuff that's very, very close to me. So these lights don't actually shine in cones. We've got flat LED panels, so I'm getting light coming in on a very sharp angle here. So if there is a lot of particulate matter, you are going to get some bounce back. We do have dimmable capabilities with the lights, and I can change whether I have the primary lights on on, the auxiliary lights on, how bright each one of those are. I can change their angles as well to try and make this a little bit more beneficial. So we've got ways to try and mitigate that. I guess I think that answers the question. There's my knowledge on lighting. So we've got a bit of a compromise here between you being able to look at anything with the current position of the lights and having the auxiliary lights as far away from the camera as is reasonable with a small frame to minimize bounce back from particles in front of the camera. Great question. So with the current system, our max resolution is a 1080p. I know we're working on some 4K options. The thing is, when we're trying to keep a thin tether, there's a limit to the amount of bandwidth. If I'm not bulking up to a giant like 6 or 8 millimeter tether with huge copper wires inside, I can't send up super high resolution video. So we found that in a lot of our testing, if you have your really high resolution sonar and your GPS data, as well as your 4K video streaming all at the same time, you can run into bitrate issues. So generally speaking, with the Revolutions and right now with the early pivots, we're maxing out at 1080p. In theory, it's possible to put a 4K camera in there, but then you might need to switch that camera if you installed a sonar. The camera head rotates. So, oh, I thought I turned the unit on. I can just show you by hand. So the camera head rotates through 220 degrees. So what you're seeing here is a slip clutch mechanism. So you can't accidentally turn it and break the gears inside. So that camera rotates. And just like you'd be accustomed to with our DTG3 or a Revolution, the unit has a sensor pod built into it. So the sensor pod is sitting underneath the carbon fiber shell right about here. It's got an accelerometer, gyroscope, magnetometer, depth sensor, water temperature sensor. It's able to tell the ROV's position in space, so where it's sitting, and then the unit will automatically, as the ROV rotates, rotate the camera head to match that motion. So it's sort of stabilizing like a slow gimbaled action in the front. The ROV will sit level in the water all the time, and it's ballasted and designed that way. So the top here, underneath the carbon fiber, is a buoyant sea foam, and so we've got sort of the light parts on top, the heavy parts on the bottom. It's almost like dihedral, like the angle, vertical angle on the wings of an airplane. It sits heavy, it sits very, very flat. Now we do have our 2 vertical thrusters as well. So there's an algorithm built into the system to recognize if it's pitched, and it's gonna fire up the vertical thrusters to counteract that pitch. So you've got sort of a passive sort of balance, both in terms of roll and pitch, as well as some active pitch control. And I'll just show you here, if JC can zoom in a little bit on the camera. As I pitch the ROV, it should, you know what, I think because it's out of water and the water detection is going on, it's not responding to my motion as clearly. I'm gonna take this right off so I hold the controller. But I'll show you that motion with the camera head. All the way up, all the way down. And the tilt shelf, same joystick, just the opposite direction. I'll hang it right over the edge here. Try not to drop the ROV. So the tilt shelf is not going to auto stabilize. It's just the camera head that stabilizes. The tilt shelf is going to stay at whatever angle it is set to. And we're able to get an angle readout on our controller from that tilt shelf, as well as an angle readout of the camera head. So you always have sort of visual data right on screen to help you know what you're looking at, where you're pointed, and where your tools are. Great. Oh. You're welcome. All right, that's a fantastic question. So we're asking about video streaming capabilities. The short answer to whoever it was that wrote that is yes to everything. So we have an Ethernet port on the back of our controller right in the center here. So I can plug an Ethernet cable into the ROV controller and plug that into a laptop. I can basically take over the sonar. So I can get the sonar on my computer screen. And if I wanted to share that, I could screen share that sonar. Alternatively, we can do a LAN stream through VLC Media Player. It works best. There's a little streaming option under Tools, I believe, and you type in the IP address of the camera, and you're immediately going to be getting the direct camera feed from the ROV. Now, if you're trying to share this live, you're screen sharing what's on your screen, so there's inevitably going to be some loss in quality and some loss in frame rate. So the way you get quality stream is basically the same way that we're streaming to you from our mirrorless camera right now. So there is a micro HDMI port on the back of the controller here. So it's not mini, it's micro, it's the tiniest one. And also a little clip here so you can connect your cable so nothing gets twisted out of the way. So you plug your micro HDMI plug in here into a standard or whatever sized HDMI cable, and then you take the capture device. So right now we're streaming from a $15 HDMI capture card that I bought on Amazon just for doing stuff like this. It's the size of a USB stick. It's got a USB plug on one end, a full-sized female HDMI port on the other end, and I just plug it into my computer. My computer sees it as a webcam. So for the highest quality video streaming, you pick up one of those and an HDMI cable, and you're able to stream in real time from the camera. I think that. Okay. Okay, so I'm not a price expert. I don't do a lot of sales, but I just had one of my colleagues help me out. So for pricing of this unit internationally, the smart package, so smart package being a very basic setup with no attachments, is starting at, you said $19.99, so $19,999 US dollars. I'm live? Perfect. Okay, so batteries, I'll just show you here very briefly. I'm going to disable motors just to make sure my fingers are safe. Perfect. So I'm going to spin this around. So what you can see here is our battery tubes are held in place with some horizontal rings. There is a set screw at the end, which you loosen off. You don't need to take all the way out. And then there's a pin, which I can pop out. And then if I pull, I don't want to fuss with it too much right now, but if I pull this out, I should be able to get the battery to completely unlock. And it just pops out, and the next one pops right in. I'm live now. Max speed, I believe we're estimating is about 2.5 knots. I mean, if you're in the ocean environment, we're thinking waves and currents. So, I mean, really, I guess it depends on that environment. When you're near the surface with a lot of waves banging you around, that's going to slow you down significantly. But if you go down even just 2 or 3 meters, you'll find that it moves a lot smoother. A unit with, I'll mention this off a little bit of a side note here, but I think it's interesting. A unit with a Doppler velocity log sensor is measuring that horizontal velocity and automatically fighting it. So if you're near the surface and normally the unit would be sort of splashing back and forth with waves, it's going to be actively firing up the thrusters and holding much more stable than a unit without the Doppler velocity log sensor. That's a really cool add-on that I'm excited about. So maximum depth of this unit is about 300, or not about, it is 300 meters. We actually have a pressure vessel in the back of our shop. It's large, like I would never want to get inside it, but I could fit inside it. And we pressurize that up to, I'm not sure what the pressure is, but it's 300 meters or 305 meters of depth for a minimum of 2 hours before we pull it out to meet our quality control standards. And while it's under pressure, we actually have some production test mode runs where you're basically firing up every thruster, moving the grabber claw, moving the tilt shelf, moving the camera head. So everything's moving nonstop until the batteries die, basically for a minimum of 2 hours. And then we pull the system out, and we'll then do some low pressure testing, both before and after the high pressure testing. What was the second part of that? Grabber attachments, right. So we've got a suite of grabber attachments. The system here, JC, if you wouldn't mind zooming in on the grabber for me. I'm just going to angle this down a little bit. So what you can see here, so the grabber opens and closes, as well as turns left and right. So to replace the grabber, what we're going to do is open it up all the way. I'll disable motors just to make sure my fingers are safe. Set that to one of the hotkeys on the controller. There's 2 thumb screws. Okay. And maybe I'm not out all the way. And I just pop it on and off. So we've got a little, I've got a little, what's it called? Dovetail that it slots into. So I can really easily swap out different types. I have a tri-gripper, so essentially the same claws, but there's 3 of them. It's very good for opening up round objects or picking up round objects. We've got interlocking claws that are a little bit bigger than this, but the tips have a little bit of a fid and it slides into itself. So it's good for going around something that you then want to pull up. And then we also have a large interlocking claw, so they're about this big. Sometimes we colloquially call them limb grabbers. They're very effective for search and rescue, for holding onto a lost soul while divers come down to recover the body. We have Sediment Sampler. We've got 2 types of sediment samplers. We've got different sized water samplers, so as they open and close, they draw in water like a syringe. We have a caliper. So as it pinches on something, there's actually a scale that can be read by the camera, so you can measure the thickness of different objects. I think that's it. With the pivot, that's it for grabber claws. We've got a few attachments that we've been testing. So we've got a rotary cutter that we've been testing. That's really good for, right now, it's really good for cutting through ropes. I think that's it for right now. In terms of tool attachments. Great question. We cannot control the pitch of the ROV. Like I was describing earlier, it's engineered to sit very, very flat in the water. And instead of the ROV pitching, what we're doing is we're pitching our tools or we're pitching our camera. And that gives us a very stable platform with which we can make adjustments and run different systems. Okay, so we actually have 3 packages of robot. They're called the Smart package, the Expert package, and the Nav package. So Smart is just a stripped down unit. It's very basic, no tools. The Expert is going to give you the grabber claw, and the Nav package is going to come with USBL and Doppler velocity log sensor. So it just depends which package you get. And in terms of which claws you get, again, it depends on the package. You can buy a set of all of them. You can buy a set of a couple. You can buy them individually a la carte. Can ship them out to you afterwards. As you can see, super easy to swap and replace. Okay, so the last question was about ballasting. Ballasting is a very in-depth topic that we could get into, but very briefly, there's something interesting about the way we ballast this unit that's different than the way we ballast the GTG3 or Revolution or some of the other ROVs that are out there on the market. So like you would see in a standard ROV, or like you've seen in some of our previous ROVs, I'll just turn sideways. JC, if you wouldn't mind zooming in on the corner here, you'll notice we have some thumb screws. So these thumb screws can loosen. We have plates actually that just slot over top and slide down. So it's a toolless system for adding and removing plates. So we've got these thumb screws on all four corners. This allows us to adjust the unit sort of position. So if it's floating in the water and it has a little bit of positive roll and say negative pitch, then what I can do is add weights to both sides on the front to bring the front down, and then a little more on the left to roll a little bit to the left. Got it. JC's giving me the symbol that the camera we're filming on's battery is flashing low. So we might cut off in just a moment. We'll at least have some audio, and we're basically done. This is the last question, so the timing works out perfectly. Very quickly, hopefully I can get you this visual before the ROV runs out of, or the camera runs out of power. Unique to the pivot, different than anything you've ever seen before. The unit is actually ballasted to be heavy, and we add different amounts of buoyant foam based on the number of tools we have attached. So the carbon fiber lifts off and we can adjust how many pieces of buoyant foam are in here. And that's gonna bring down your overall weight. So I don't have a light unit that I'm filling up with weights to be neutral. I've got a unit that's inherently heavy